Question 6 is our precedence tables critical path analysis question. So we're looking at that chart at the top and trying to figure out what's happening. Precedence means what comes before. So if you set a precedent for something, it means you establish a way of doing things, it's something that's come before. So when we're asked to fill out a precedence table, that's what we're doing. For each of the activities that are listed here at the bottom, we're looking for which activities come immediately before it, which ones go into that next activity. Now remember, the really important thing about critical paths is that it's the lines on here which are the activities, it's not the nodes. These numbers are not activities, it's actually the arrows which are the activities. They've already started off the table for us, so all we've got to do is fill in the gaps. Let's start by looking at F. F is here. We need to look at the items, the activities that are going into this node here, which F is coming out of. So those two are quite simply B and E. There's nothing complex, no trick question there, so we just need to write B and E in this gap here. Now, exactly the same thing applies to G. You can see G is also coming out of this bit here. So again, we write B and E as the immediately preceding activities. Now, let's have a look at H over here. H, quite simply, only has C going into it. Nice and easy. So for H, we're going to write a C. Let me fix that. There we go. So that's a C for that one. It gets a little bit more complicated for I and J, but not that much more complicated. I is up here. Now remember, these dotted lines are our dummies. We don't care about this dummy here because it's going away from this number 5 for I. So we're just looking at what's going into I. Well, for I, it is D and it's F. J, however, is affected by the dummy going down. J is this activity here. Now, what is coming into this 6 node here? Well, we've got the obvious one. We've got G. So we may as well write that down. But then we've got to think about actually what is a dummy. A dummy is just, it's still actually going into that number 6. It's just we couldn't draw it that way because there would be multiple things coming in. We wanted this H coming out as well, and we couldn't have that H coming out just here if we also joined that one up there. So we had to draw it dotted. But that doesn't change the fact it's definitely coming up here, and it's definitely going into J. So these two dummies here, coming down here and up here, are definitely still included, and we need to write them down. So we're also going to write down C, D, and also F, because if you look up here, be really careful, we've got both D and F coming into that 5, so we really can't leave either of them out. We've now got to start filling out early and late times, so we're thinking carefully about what time these possible activities could start and finish. We're going to start by doing the early event time, so we're going to start by doing the top boxes of all of these, and we're going to do that by travelling in this direction, going forwards, making our numbers as big as we can. Now you might think, why are we making them big when it says early? Wouldn't early suggest that actually we want that time to be as small as possible? We're going to make it as big as possible because we want to be sure that whatever time we end up with in this top box, that person can definitely start that activity then. We know that the other people finish their jobs, so that person will actually be able to start their activity at that time. Let's go through and show you how it gets started. We can always fill in 0, 0 in the first box because it's a start, right? And I'm just going to go through the boxes, going left to right, filling in the times. A5, that's the only way up to this box up here at the top, so I can fill out 5 up there. There is no other way to get up to this node up here. So I'm more than happy just to fill that out with a 5. The same with the one at the end of C here. There's one way, and one way only, to get to that box, so I'm happy to fill it out with a 14. When it gets a little bit trickier, and when we actually have to start using our brain a little bit more, is with these complicated ones in the middle, where we've got multiple routes to get to it, and we need to consider which is the highest number to get there. So, let's start with this one here now. I have to have completed all of the ones coming before it before I can fill this in. So if there was another route, let's say from here to here into that one, I couldn't fill this one out before I'd filled that one out. But it's fine. I've sorted both this one and this one. These two are both filled in. So I can now consider, is 0 plus 9 going this way, or 5 plus 3 going this way? Which one is bigger? Well, clearly 0 plus 9, so I'm going to fill that one out with a 9 there. And that's that one done. Let's keep moving on. I'm now going to look at this one at the bottom here, because that looks quite straightforward to do. I can only see one route there, that's this one. I'm going to take this number, 14, plus 10, is going to give me 24. So I'm going to fill out 24 just like that. Now, I am going to choose to do this one here next. I'm not going to do this one because I can't do this one before I fill out this one. Look at this dummy. There's a connection there. And I definitely can't do this one because I haven't filled out this box or this box, which both lead into it. So for this one up here, I could either do 5 plus 4 there, or I could do 9 plus 2. Which one's bigger? Well, 9 plus 2 is 11. So I'm going to type in 11 there, and that one's done. I'm moving on now. I'm going to look at this box. I could either do 9 plus 3, giving me 12, or I could do 14 plus 0. This is a dummy. A dummy never has any weight. It has a weight of 0, so 14 plus 0. Then my third option is 11 plus 0 there. It's really important we consider each and every option coming into this box. The biggest there is obviously 14, so I'm going to write 14 in there. That leaves me one box to finish off so that I've finished all of my early event times, and that's this one here. I can see I've got 3 lines coming in here, so I need to consider 3 options. Either 11 plus 5 giving me 16, 14 plus 3 giving me 17, or 24 plus 4 giving me 28. 28 is the biggest, so I'm going to fill in 28 just like that. Okay, I have now done all my early event times. Next up is my late event times. For this one, I need to be going backwards this way, making my numbers as small as possible, and I'm obviously going to do that by subtracting the largest number I can. So I'm subtracting the numbers because I'm going backwards. I'm going to subtract the biggest number I can so that my late event times are as small as possible. Let's start. We always start by writing, just copying down our final time from our top box to our bottom box. So these two are always identical. That is where we get started. Then I need to be travelling backwards. Let's travel back up to one where there's only one route back into it. So I'm going to choose this one because that's quite straightforward. For example, if I looked at this one, this is a little bit more complicated because there are 2 routes back into it. I'm going to start with the easiest ones I can, so I'll start with this one here. The only way to get back down here is 28 minus 4, which is going to give me 24, so I'll fill out 24 there. The next one I'm going to look at is going to be this one here, because as before, that one only has one route. There's only one way back into it, which another way of thinking that, I guess, is saying there's one route forwards out of it, so that's the only one I have to think about. What I'm going to do is I'm going to do 28 minus 3, so that gives me 25. So the number I'm going to write there is 25. Now I'm going to have to consider this one at the top. So I'm now looking and I'm considering what's the one I want. Do I want 28 minus 5, which would give me 23, or do I want to go 25 minus 0, which would give me 25? So 23 or 25. Remember, I want to make those numbers as small as possible, so I'm going to go for 23 there. Let's travel further back still. I'm going to go for this one next. Now, I'm going to go for that one next because I know that this one and this one, which are the roots out of it, have both been filled out. I couldn't do this one because, look, I don't know this yet, and this would be a possible route back to it. So let's think about this now. I could do 23 minus 2 would give me 21, or 25 minus 3 would give me 22. 21 is smaller, so I'm going to stick 21 in like that. Let's think about this one at the top next. I have two options. I have either 21 minus 3 to give me 18, or I have 23 minus 4 to give me 19. I want the smaller one, so I'm going to go 18 like that. The last one I need to consider is this one down here. I could either come back from here, or I could come back from here. That's 24 minus 10 would give me 14, or 25 minus 0 would give me 25. Very clearly, 14 is lower, so I'm going to write in 14 like that. Now, I should be able to check that I have got a way that actually makes that last bit there all the way back to the start point. That actually makes that 0, 0. So I do here because 14 minus 14 would give me 0. And that is a little bit of a check that I haven't gone drastically wrong. The next thing we're looking at is the second part of the question, the total float for activity E. So activity E is this one here. Now, I always think of the total float as sort of the slack. The time where, if you're thinking about this being a man called Mr. Elliot, for example, how much time can Mr. Elliot sit and waste? Well, to figure that out, we need to figure out the earliest time he could start, plus the time it would actually take. Well, that gives us 5 plus 3 equals 8. So the earliest time he could, in theory, finish is after 8 hours. Or whatever the unit is in this question, I haven't actually checked, but assuming it's hours, he could finish after 8 hours. But we know that in theory, if we're giving him the maximum slack we could, he has got up to 21 hours. So how much slack does it give him? Well, it gives him whatever the difference is between 21 and 8. So we're going to do 21, subtract 8, gives us our float of 13. So our float, our final answer for our float is 13. We've now come to the part where we're going to make use of our early and late times quite a lot, and we're going to actually make some decisions about who's going to do what when. First thing we've been asked to do is calculate a lower bound. This is actually quite similar in structure to the lower bounds you'll see in bin packing and some of the other areas of maths. What we're really doing when we're finding the lower bound is we're summing up everything and then dividing by the chunks of time that there are. So, in this case, we're looking at all of the total times and we're considering, actually, if there was no scheduling conflicts or anything like that, what would the minimum number of workers we'd need to be? So, we need to add up all of those numbers. I'm not talking about the numbers in the boxes, I'm talking about the actual times that the different activities take. I'm adding up all of these, and you'll have to take my word for it, but that comes to 62. I won't write that all out. That comes to 62. So all of those individual activities add up to 62 hours. But we don't have 62 hours or days. I haven't actually checked what the unit says. And we want it to be done in 28 hours or days or whatever it is. So we need to divide that by 28 to see what that comes out as. Well, that comes out as 2.21. Unfortunately, it's not possible to employ 2 and roughly quarter of a man. So we're going to have to round that up, as we always do for lower bounds. We round that up to the nearest, up to the next integer, not the nearest one. So that's going to be 3 workers that are required as our lower bound. Now that may not actually be possible. It might not be possible to have those 3 workers. We might need more. But it's definitely not possible to do it with 2 or 1 workers. The final thing we want to do is fill in a Gantt chart, which will allow us to actually schedule who is doing what when. Now, I'm always going to start by filling in my critical activities. Now I can spot my critical activities by the fact that the early and late times are the same. They are the path where there is 0 float. So those should slot in really nicely straight across the top with no gaps. They are the ones that have to happen with no slack, no messing about with them. So let's fill those in first. Actually, I'm just going to write out exactly what all my activities are so that I can tick them off when I've done them. That'll make it easier for me to make sure that I'm not missing out any of my activities. H, I, J, K is my last one. Okay, so I'm going to start by filling out my critical activities. As I said, the first one I've got is going from 0 to 14. And that is activity C. So I'm going to fill that in. I'm going to label it activity C. The next one I need to put in is activity H, which is going up to 24. I'm going to put it in like that. You would obviously be able to do it more neater than I can with my fat fingers on my iPad. So that's going up to 24. And then my final activity, my final critical activity is K, which goes up to 28, which takes us to our final time. So we're putting in K like that. Now C, H and K have now been done. We can now think about scheduling the other activities. Now I know for a fact, because of visually here I can see these are all coming from the start point here, that A and B can start at the same time at the front here. So let me put in those 2 both at the same time. That is a bit of a messy A, and this is a B going up to 9. Now the reason that I've put those both there now is because I know that otherwise I'd just have some dead time at the beginning here, because nothing else can happen until those two have been done. I can't be doing all of this mess until I've got A and B out of the way, so I may as well stick them down to begin with. So let's cross off A and B, and then think about what we can put where next. Well, let's just have a bit of a play. I know that E and D both have to happen after A. I'm going to stick E in here, so E is going to be another 3 hours after 5, so it's going up to 8 there. That's E sticking in there. Now, after that, what can I do? D also is coming after A, and I've done A there, so technically I could put it anywhere, but why not just stick it up at the top here, because I know that that will take me, those 4 hours won't take me over the 23 I'm allowed, so that's okay. So I'll take me up to 12 there, like that, and I'll label that D. Okay, let's keep thinking now what we're going to do next. I've done D. I've got F, G, I and J still to come. F and G must happen after E is finished, but that's okay because look, even when B is happening, E is already done, so that's okay. So let's start thinking about where I could schedule F and G. I may as well just put them after each other here like this. F there for 2 and G for 3 more after that, like that. Happy enough with that, no real problems. And the final thing I've got to think about is I and J. Now I has to happen after F is finished. That's okay, even if I stick it up here, F will have been finished, so I'm okay with that. I think I'm going to stick it there, so I'm going to say I and has to start after 11, which is fine because we're starting at 12 there. So let's stick in I going from 12 up to 17. So we'll stick it just like that. Label that I. And finally of all, J. Now J can start after 14 and it goes on for 3. So that's perfect there because that is exactly on 14. It's going to go on for 3, J, stick it in like that and cross it off. Now it's absolutely crucial that I check what I've done. That I check that every single precedence is actually being listened to. So if I look at J, that everything that's come before it is actually coming before it. You need to do that whole check for this whole diagram. Now, you'll have noticed that this isn't the same as some of the Gantt charts you've seen where you've had boxes with then the dotted lines afterwards. That's because we've got to read this question carefully. It says schedule the activities using the minimum number of workers. So we knew we were looking for a way where we use 3 workers. We weren't looking for all the possibilities. That's why you have the dotted lines. We were looking for an actual way that you could schedule it with 3 workers. So that's good enough. I'm sure there are other ways as well. Swap things around a bit, that's not a problem. Because look how much slack we've got here. We've got loads of spare time. But as long as it obeys everything that you've written about up here, so it obeys the early times, it obeys the late times, it is right length, and it has the right precedence coming before it, you will get full marks for it.